Good morning everyone. In previous class, we discussed the slab culvert. First of all, we calculate Ece-Ii excavation. After that, we calculate the cement concrete part. Then we discuss about the first class brickwork in 1:4 cement mortar. Then after that, the last part, RCC work 1:2:4 in slab excluding steel. Okay. Here we discuss in today's class steel bar including bending in RCC work. It means in this case we only calculate the number of steel bar used in construction, okay, or used in the slab of culvert. The first, here we find out the how many numbers of bar used, what are the diameters of the bar, and what are the types of bar used in RCC slab case. First of all, you have to know about the types of bar and its conditions. Okay. First is in RCC slab culvert, the main bar is used, and other one is distribution bar is used. What in by main bar? What in by distribution bar? The main bar lies in RCC slab in short span. It means the length lies in RCC slab in breadthwise. Okay. And in case of distribution bar lies in RCC slab in lengthwise, or we can write here long. This lies on lengthwise. Okay. Then after that, the main bar is further divided into two types. One is main straight bar, another one is main bent up bar. Okay. In main straight bar and main bent up bar, both diameter are same, and center to center distance of flying the bar also same. The only difference between the bar is varied only in length case, or the both bar is provided in the RCC slab. The main straight bar is one more than from the main bent up bar, because the straight bar lies in RCC slab. From it is an alternative way, but for starting point and ending point must be the straight bar is provided in case of bar binding. So the number of bar in case of main straight bar, or in case of main bar, the straight bar is one or more than the bent up bar. Okay, clear? Then we are going to the dimension part. So how can we define the dimension? How can we define the length? Dimension is already mentioned in diagram. Okay, and center to center distance we already mentioned. By using center to center distance, dimensions, and length and breadth, we can define the main bar diameter and distribution bar diameter. Okay. So first of all, how can we define the length? How can we define the breadth? Okay. Length of main bar. How can we define the length of main bar? Length of main bar is equal to breadth of the section minus 2 into side cover in plus 2 into hooks. This is the formula for length of main straight bar. But breadth of the section minus 2 into side cover plus 2 into hooks. So first of all, we consider the breadth of the RCC slab minus 2 into side cover. In slab case, the side cover normally provided in 4 centimeter. 4 centimeter. So 2 into 4 centimeter plus 2 into hooks. What do you mean by hooks? Hooks is same to the same diameter contained with the main straight bar. It is provided the end point of the bar to hold the bar in position. Okay. So hooks is diameter is normally two numbers, two sides of the two sides of a main bar or a bent bar. We provided hooks. Normally hooks are 9-5. What do you mean 9-5? 9-5 means the 9 times of diameter of the bar. Whatever the diameter we use for the construction or for the bar, it is considered in the hook is considered 9 times of the diameter of the bar, or we can write here hook is 9-5. Okay. After that we can define the length. Then in case of bent bar, how can we calculate the length? The bent bar case, the length of main bar plus adding one depth. One depth means what? One depth for two bent ups. We already know bent up bar have some angles, straight some angles. This is contain 45 degree. So the bent up bar is extra longer than main straight bar. Straight bar have no angles, but bent up bar is the angular person. So in case of bent up bar, the length of straight bar plus 16 centimeter for two bent up. Okay. For the bent up, we consider 16 centimeter. After that, we are going through the numbers of bar calculation. How can we calculate the number of bar? In case of main bar, the number of bar is calculated by the formula. Write down. Number of bar is equal to length of the slab by center to center distance of bar. Write down. Length of the slab by center to center distance of the bar. Okay. We can define the number of bar. How much number of bar we define? Then it's divided in two types. It's divided in two. Okay. Suppose 33 numbers of bar is defined. Either 32 number of bar is defined. After that we divide it in by 2. Okay. Then 16 and 16 is equally we get. Okay. But in case of main straight bar, we can add extra 1 as compared to the main bent up bar. Okay. Suppose the 16 numbers of bar is defined by the rules by using the formula of numbers of bar. Then for main bent up bar we consider 16. So the main straight bar we consider 16 plus 1, which is 17. Okay. Now first of all we discuss about or we study the diagram when the diameter of the bar is given and center to center distance is given and the length and breadth is given. The length and breadth part we already discussed. We already know the slab contains 4.80 meter length and breadth is 2.10 meter. Okay. Thickness already know. Right. 20 centimeter thickness. So let us discuss where the details part of main straight bar and its diameter and its center to center distance. Okay. 2D time is over. The remaining part we discuss in next class.